So I come from Australia. Parents taught me mainly to do law and actuarial. Every single day I wanted to change. And that was in fact used by NASA, PyTorch, SciPy, and also NVIDIA. I think if you just give me a resume, I think it's a relatively good signal. It's much higher probability for me to reach out to people if they solve one issue. So sometimes in some layers, there is one number. There's just one number which you must not quantize. And if you quantize it, your whole model will break. Okay, some people don't like us for this. We will read Python code on the fly, edit it, save it to a Python file, and then import from that new file. It's kind of like a compiler. So my view is over time, yes, if you scale RL to large scales, you will see interesting phenomena. My take is, if the probability of a positive reward is more than 0, you will get a very powerful model.
So hello, ladies and gentlemen, welcome back to another episode of Ground Zero AI Talks. And yeah, it's episode 5, I guess. So today I'm speaking with Daniel Han, founder of Unsloth, where they are making LLMs, fine-tuning faster, cheaper, and more efficient. We'll go through his early journey from studying law, actuarial science, to diving deep into AI, building open source projects, and eventually starting his own company, Unsloth, which is pretty much renowned in open source community. So hi Daniel, how are you feeling?
Hello. Thanks a lot for inviting me. I'm super excited to talk about Unsloth and everything that we do. Much appreciated.
So yeah, let me talk about Ground Zero. We do a lot of foundational stuff, culture, and postcards as well here. So recently we did a pod with Soham Parekh, everyone's favorite founding engineer, Will Brown, token builder. So yeah, I guess it's a good source for you all to actually listen from one of the top minds in the field. So yeah, we can get started about who is actually Daniel Han. So let's start with your education, Dan. You actually began in law and actuarial studies, not the usual starting point for someone who ends up building some of the fastest ML tooling around. What drew you to this field actually? And what was the pivot point that led you to AI and engineering? Yep.
Yeah, so I come from Australia, and in Australia, the top professions are law, actuarial, medicine, the old school type, the highest, most important professions. So yeah, my parents taught me mainly to do law and actuarial. So so that's probably why I did law and actuarial. It's fine. It was okay. I did it for 1 year-ish. And then every single day I wanted to change. After convincing my parents, after a long year of convincing, finally I transferred into data science. So UNSW, so the University of New South Wales in Australia has this new degree called data science. So I did that instead. So I transferred over. And then I majored in computer science and maths. So that was kind of my uni journey. It was a bit weird, so I do know some law, I do know some actuarial science, I know some economics and stuff like that. So it's very diverse subjects and stuff. My favorite is still maths and computer science.
Interesting. And I guess you spent a lot of time at University of South Wales, not just studying, but teaching, running the data science societies, shaping projects. So what was the period for you? How did courses, teaching, and community work shape your thinking around machine learning and performance?
Yes, I was a teaching assistant, and I was an assistant lecturer type in UNSW. So I was teaching something called marketing analytics, where you can use data science to try to produce good outcomes for marketing scenarios. It was pretty fun, teaching people how to use Tableau, teaching people how to do data visualization, very basic machine learning and stuff. It was mainly to try to educate people how to use data science more effectively. This was in the olden days, right? So this is many years ago when linear regression, logistic regression, this was still very popular. Decision trees and stuff like this. But nowadays, no one, more people just use, general language models and stuff like that. But this was, much long time ago.
I guess it's been pretty long journey, I guess, for it will be coming to a decade in a while when you passed out grad school, for sure. Next up, I would like to know about more about Hyperlearn and Sciblox. These are projects that didn't just live on GitHub, And actually, they ended up being used in places like NASA, PyTorch, SciPy, and even NVIDIA. So, what was the core problem you were trying to solve with these libraries, and how did they evolve into something that large organizations started adopting? Yeah.
Yeah. Yes, my first open source package was in fact Sciblox. It, it was not a very good package. It was generally just a conglomeration of random functions. Very bad. It was not a very good package, but it was my first ever package that I released to the open source community. It was okay. It was mainly for data science, for machine learning. It was like more like a toolkit of like easy functions. I would not suggest anyone to use it. I don't maintain it anymore. But yes, the second package was in fact Hyperlearn. So Hyperlearn made machine learning faster. Many algorithms, linear regression, principal component analysis, PCA, SVD, randomized linear algebra, mainly the old style type, machine learning algorithms. But yes, the goal was to make those algorithms faster. So the mathematical ones much faster. And that was in fact used by NASA, PyTorch, SciPy. I contributed some of the things into like larger packages. And also like, NVIDIA, other organizations also use it. There was quite a few research papers also using some of Hyperlearn's methods. But this is kind of like a precursor to Unsloth. But yeah, Hyperlearn still works, but I don't maintain it anymore. Yeah.
I guess that was pretty much your foundational work which you started with, and it eventually turned up to use by some really good organizations. And also, I would like to know more about your journey with this performance engineering, which you started back then and still doing. Yeah.
Yeah, yes, Hyperlearn is still used by large organizations. Some of the methodologies are more like integrated in large packages. So if you do like singular value decomposition, principal component analysis, all of the methods are like, they're all integrated inside of like NumPy, SciPy, and stuff like that. And also like QML, some of NVIDIA's packages as well. I think the primary objective of these packages is just to increase performance, but also to reduce memory usage. Like there's many ways you can reduce memory usage and also increase performance. So the goal was to like think about, okay, how do we do both at the same time? And also how do we not reduce accuracy, right? So that's actually one of the biggest issues is like, okay, you can make stuff faster, but you need to retain accuracy. So that's kind of like the three thinking ways for performance engineering.
Very interesting. And probably like at some point, it seems like speeding up ML workloads became your thing. So was there a moment where you realized that this was a problem you deeply wanted to solve, a metric, a bottleneck, maybe a frustrating experience as well that crystallized your focus to pivot in the area? Yeah.
Yes, it was mainly like a problem. It was a personal problem. Like we don't really have very good computers. The GPUs are quite bad. Some of our computers don't even have GPUs. So it was relatively, it was forced. It was kind of like forced optimization. Like we had to make it faster. We had to reduce memory usage. It was mainly for our own use cases. So it was a necessity for us to make it faster. And so it kind of like, it was not really a problem that we're trying to solve for someone else. It was more a problem we're trying to solve for ourselves. And then we noticed, oh, okay, other people have the same issue. And so like, that's kind of like why these packages exist. It wasn't for like, we're trying to solve other people's problems. It was just like self problem.
So you didn't have expected like it will turn out to something like that, but yeah, it's like it's your problem, and you try to iterate a lot solving that, and eventually it turned out to be a big problem, and actually a big problem to be solved for a good use case. Pretty interesting.
Yeah.
Um,
I didn't expect it. Like, I think like, yeah, I didn't expect other people to have the same issue. It was mainly like, okay, you might have bad resources, but also if you do have resources, like, if you do have good GPUs, it will still be beneficial for you. So like, yeah, it was kind of like a two-sided thing. Yeah.
Interesting. And also, like I got this question since you were a bug bounty guy in LLMs. What was the most interesting one you found, and how did that experience shape your intuition as a founder?
Yeah, so we do find bugs in the open source language models. So for example, there are a few bugs in Gemma, Llama, Mistral, Quen, even DeepSeek, Kimi. we essentially try to contribute fixes to the open source community. For example, like just a few days ago, we helped fix a system chat prompt issue with Kimi Chat, the 1 trillion parameter model. For Llama, we fixed a few chat template bugs. For Gemma, we fixed like implementation details. Generally, it's not actually that complicated to find these bugs. I think it's more like you need to understand how a transformer works. You have to sit there and sift through the entire implementation and find, oh, okay, this is a bug, this is the issue. And also like verifying the bugs, actual bugs, that is actually a longer process. So you do need to communicate with the large model lab teams, like, oh, okay, is this a bug? It might not be a bug. So like, it takes time and energy to like find these issues over time. It is very interesting. Like, we try our best. We will communicate as many issues as possible to the open source community. Yeah.
Really interesting. And I guess this has led to some of the interesting problems. I guess recent hirings from Unsloth has been like, try this problem, you will get this bounty of $500 and stuff. I guess the early journey has pretty much inspired a lot, bringing this novelty in the stuff. Yeah.
Yeah, I think like we did make a challenge for people to, essentially if you have bugs, if you find bugs in an open source package, we will like reward you for that. We do allow, like we provided like a challenge where we like wrote, okay, these are some bugs you could solve. And then if you solve them, there is a bounty for it. But yes, we do value people solving issues and bugs. We find that to be the best learning method. Like you don't need to learn what AI is or like, how to code up a transformer. But if you can find bugs, it's like the same teaching methodology. So we find that to be very effective.
Is this your normal hiring process in Unsloth as well? Like finding bugs and...
Yes, it is.
Oh, okay.
So if you find bugs, the more bugs you find in Unsloth, higher the chance I will reach out to you. Yes, correct. I think if you just give me a resume or like, some sort of a GitHub package, I don't think it's a relatively good signal, whether you can like fix issues in like language models. It's much higher probability for me to like reach out to people if they solve one issue. If you solve two, oh, okay, then you know what you're doing. Like, then, that's a very high probability, of getting accepted. But yes, correct. If you solve bugs, I will reach out to you. Yes.
Pretty interesting. I guess this will give pretty much idea to the people if they're work on the very low levels in the Unsloth team. You need to find bugs and reach out to Daniel. Interesting. So next is like all the top labs seem to be like this. This question pretty much stuck to me for a long time. So all the top labs seem to be converging on the same kind of thinking model, like chain of thought, reasoning focus, tool using agents. Is that because people explored widely and this was the only thing that actually worked? Or is it more of a coordination trap where everyone just iterating on each other's paper while ignoring other viable matrices, but weirder directions as well? Yeah.
That's a good question. I think yes and no. I think yes, labs do try to like leverage methodologies from each other. So like, for example, O1 kind of did show, oh, okay, it was a kind of the first reasoning type model that was like shown to the public. And then it took like a very long time for the open source community to replicate it. Right? That's what was like DeepSeek R1. But it took a very long time delay. And currently now, there are like models which do tool calling, web search, we have the reasoning type models. And most large model labs will try to converge into this one system. Right? There's like Canvas type, there's like a Canvas, there's like web search, there's deep research, there's tools, you can search the web, the model can do a lot of things. Yes, my view is probably similar. I think like most large model labs will try to converge into this one specific type. Like, everyone's trying to build like a deep research, everyone's trying to have like agents, everyone's trying to do like, reasoning, and everyone's trying to do the same thing. I think maybe this is just a temporary thing. Mainly because everyone's trying to compete with each other. But I think once the competition, like, somewhat like, decreases a little bit, like in terms of like, oh, okay, everyone's capability looks very similar, then maybe companies will try to like venture out, oh, okay, we will focus on something else and stuff like that. I do agree, like temporarily, I think maybe for the next, maybe 1 year, everyone will just compete with each other and all the models will look similar. Yeah, that's kind of, yeah.
Interesting. So like, do you see like what more could be the areas where these big frontier labs should explore? Not usually the current standard, but something that could be phenomenally later ahead of time. Yeah.
I think with reinforcement learning, for example, there is like a approximate, it's not a theorem, it's like an approximate, it's not a, I don't know how to say it, but it's like a conjecture. Okay, this is my conjecture. Essentially, if the language model can answer with some probability, right, like not zero probability, like some probability, like more than zero, right, and it can get an answer right with more than zero probability, in the limit, if you execute the reinforcement learning algorithm to infinity, it will obviously solve the reward function. Right? So like I think that's kind of where large labs are trying to head for. They're essentially trying to scale RL to like maximum, to the maximum limit as much as possible. And I think that's their goal, right? The goal of large model labs is to scale RL to infinite scale. Okay, obviously not. There's no such thing as infinity, but like as much as possible. And that is how they're trying to get an AGI. That's from what I understand. So large model labs are just trying to scale RL to like massive scales. And that's kind of like where the majority of like most people are trying to go for. In terms of other ideas, it's still an active area of research. My view is reinforcement learning does seem to work very well. If you give it like multiple reward functions, multiple environments, and you just scale it up, it does seem to work. But we're not sure, how far this will go. And so that's where all the large model labs are trying to go for. It's more like an experimentation phase. Yeah.
That makes sense actually. The next is about before rewriting kernels in Triton, what mental model do you use to decide if it's worth the effort? Do different architectures meaningfully changed how memory and speed trade-offs play out, or is that mostly a myth? Yeah.
That's a good question. I think there are like two different factors. Obviously, the first one is you should not optimize just like every single line. That's probably not a good idea. You should use some sort of like benchmarking tool to see, oh, okay, this function seems to be very important to optimize. So you should optimize it. For like small little things, maybe just ignore it. You're gonna get like a 5% boost. It's not that important. But I think like currently, if I had to tell people to like optimize stuff, you should use torch compile first. See how far you can go with torch compile. There's like 100 different turning knobs of torch compile. So please, I always tell people, don't do Triton first. Use torch compile first, right? Use torch compile, see exactly where it goes. And then, okay, write your own Triton kernels, write your own, optimized kernels and stuff like that. But also sometimes it's not the kernels that are the most important factor, right? It's actually the mathematical algorithms that you have to like design and rethink in order to make something more efficient. For example, flash attention, right? Flash attention wasn't really it wasn't the kernels that was important. It was the rethinking of how to do batched attention, like small little, batches, and not the whole attention mechanism in one go, that actually, made it faster and also like reduce memory usage. So it's not, I wouldn't say you should write Triton kernels. I would say, you have to rethink about how the entire architecture, right? How do we parallelize this function? How do we make the function more effective? Without reducing accuracy. So generally, I will tell people not to do Triton. Yeah, it's kind of like opposite to what we do, but like, please use torch compile first. That's my main suggestion to people.
So you're more insisting on the doing more experiments, changing parameters, and get to a point where it actually start working in the optimal direction as we want.
Yeah, so for example, like torch compile has many, many different knobs. There's something called coordinate descent tuning. Do you want to turn that on? There's something called multi-kernel. Do you want to turn that on? There's group fusion. There is, epilogue fusion. I don't know. There's like tons of options. Just selecting those options will take a lot of your time, verifying if the output's correct, if the compiler actually works and stuff like that. Also, like I'm not trying to say just do torch compile. That's just one method in the toolkit. If you do want to write Triton kernels, yes, please do. Like if you know how to write a Triton kernel for some specific algorithm, do that. But I don't suggest it. My view is torch compile can get quite far. And then utilize kernels as like the last mile. Yeah, and also obviously mathematical algorithms, that is the hardest. Redesigning, making the algorithm itself more efficient without doing kernels, but also like actually rethinking the algorithm. That is probably the most hardest part of the machine learning's job. Like that's very complicated. Yeah, that will take much more effort. Yeah.
What's your view on recent advancement in one-but models and the future? Also, you rewrote several attention and rope kernels in Triton. How did you decide whether to spend 2 weeks fusing a kernel versus accepting PyTorch stock ops and moving on? Yeah.
That's a good question. So generally, if it takes two, generally when you like start working on a kernel, you can estimate in the first few days when you start writing the kernel, you can estimate, oh, okay, how long will this take? You can kind of estimate it. And if I do estimate this will take quite a long time, I'll probably just ignore it. I'll have to like think about, okay, how much performance benefit are we going to get? How much memory reduction are we going to get? If it takes too long and the results are not that good, I'll probably just ignore it. I will like maybe work on it later. Yeah, so it's not that important to do. For one-bit models, I think, yes, we released DeepSeek R1, dynamic 1.58-bit quants. They were very popular in terms of running, so you can run them on your local device. We essentially quantize layers, dynamically. Some layers are 1-bit, some layers are 2-bit, some layers are 3-bit. And we show that if you can quantize and select layers correctly, you can increase accuracy without making the model very big. So that, we're still uploading dynamic 1.58-bit quants. For example, Kimi K2, the largest 1 trillion parameter model, we did upload 1.8-bit quants. Yeah, so like we do upload these to our Hugging Face page, and we try our best to like upload as many as possible. So it's not just 1-bit quants, but like 2-bit, 3-bit, 4-bit. They're all dynamic type quants.
Interesting. Also, which hard constraints like hardware, budget, or any other limitations has improved your ability to come up with novel type of solving problems, and how did you do it? More interested in the ability of to manage constraints, or it more converges to the performance engineering itself? Yeah.
I think, okay, specifically on the algorithm side, like for example, for the algorithm side, when you look for the transformer, right? For example, when you look for the transformer, there are different modules. Like for example, there's a rope kernel, the rotary embeddings part. There's the QKD multiplication part, and then there's the attention, and then there's the LMRP part. Each of these can be modularized, and your goal is to optimize each of these modules separately. Try not to optimize them in tandem. And then once you like optimize each of these segments separately, then you can like combine them into one system. That's how you go about the algorithm side. For the hardware side, it gets more complicated. For example, Blackwell GPUs is very different from the Hopper type GPUs. They're very different, and the Hopper GPUs are very different from the Ampere GPUs. So every single time there's like a new architecture for like GPUs, for example, you do have to rethink about how to optimize them. But generally, what I generally like to tell people is maybe for the GPU type of optimizations, I would rely on NVIDIA to write, the kernels. Just call cuBLAS. For matrix multiplication, just call cuBLAS, and then try to use as many matrix multiplications as possible. And try to convert all the algorithms into matrix multiplications. The more you convert, the more efficient it will be. That's kind of what I tell people. Yeah.
On the same line, most of these LLM code bases are massive and abstracted. How do you actually go about debugging granular logic, like what's happening deep in the training loop? What's your stack and mental process for that?
So generally, it's very manual labor. So like you do have to like inject. You have to inject print statements. You have to inject, torch all closes. You have to inject. If there is a CUDA memory error, like an out of bounds error, then you have to like, oh, okay, where is it? I don't know. So there is a lot of, labor and editing of the code base in order to like find a bug. But once you like, I would say you have to be patient. You have to be patient to find issues in the training code base. It's relatively, most training code bases are fine, so they're relatively fine. But sometimes you will be able to find one bug. And so like it will just take patience. A very good example is a gradient accumulation. So for example, we fixed a bug in gradient accumulation. It was very hard to find. Like instead of like when you do gradient accumulation, you have to sum all the you have to sum the labels and then divide it at the very end. You can't just do it in intermediate steps. Otherwise your loss will be different. But it was very, very hard to find. Because like people kind of just forgot about it. And so like I would say it's more about patience and it's just patience. Yeah, that's probably the correct word. Just be patient and you will find a bug in the end. Yeah.
I'm also curious about, so while finding a bug, if you have tried or tested any language model, if it is able to find something for you, or how much you are using AI models to come to a process that, yeah, it is actually helping me to find a bug or something very interesting out of it. Yeah.
Actually, that's a good point. Like, yes, language models are pretty useful. For example, Gemini 2.5 Pro, O3, all of the reasoning time models. If you shove in the entire implementation and ask it, like, can you find a bug? Sometimes it will come up with bad, like it will say something wrong, like it will think this is a bug. So it's fine. Sometimes it actually does find a bug. It's relatively rare though. I think maybe over time they will get better. I think the best way for language models to find bugs is to actually do testing and finding bugs at the same time. For example, like, you strip out a specific area and test it. So like, I think like generally, if you add testing, if you do Python code execution at the same time, it will probably work. For example, like I was using like O3, for example. O3 has like Python code execution during the reasoning process. That's pretty good. So I think like if this can be expanded more, then it can find bugs in language models. But currently they're not very good. Yeah.
What's your most go-to model these days for anything, like at least for finding bugs or training stuff? Yeah.
Definitely Gemini 2.5 Pro, O3. Yeah, those two are probably my go-to ones. If Gemini 2.5 Pro can't find it, I'll use O3. If O3 can't find it, I'll use Gemini 2.5 Pro. Yeah, those two are my favorites. Yeah.
Interesting. I got this question from Token Vendor on Twitter. Your blog on dynamic quantization claims that just by using 10% of VRAM, you are getting FP16 accuracy. How does something still remains so accurate? What is the intuition behind being able to compress the information to 4 bits and still not losing anything? Yeah.
Yes. So the trick of dynamic quantization is you should not quantize every single layer to 4 bits. Because this will reduce your accuracy quite a lot. However, what we show is you can select 1 or 2 layers to upcast to float 16. And this will just use 10% extra VRAM. And this will actually increase the accuracy dramatically. So we show in a blog post like why this happens. So sometimes in some layers, there is like one number. There's just one number which you must not quantize. And if you quantize it to 4 bits, it will reduce accuracy dramatically. And these specific numbers are called superweights. So there is a paper about it. And so like, for example, if you quantize one specific small little number out of the 7 billion parameters or the 1.4 trillion parameters, your whole model will break. We're not sure why just this one number you cannot quantize, but it seems like language models do have this one number inside the whole language model. That's very, very important. And so the question is, how do we find this one number? And so that's kind of like where our dynamic quantization methodology comes from. Like we will try to find this one number in the model, which to not quantize, and then we will like leave the entire layer in float 16. But yeah, we show that like essentially all our uploads, for DeepSeek R1, for other like Llama Vision, Gemma and stuff like that. All of these use our dynamic methodology, and we verify like, oh, okay, this does seem to work. Yeah.
I guess this one number point you're also talking about in AMD session as well. There's a recent paper where they're talking about that one parameter metric out of billions of parameters that is enough to calibrate the stuff. Yeah.
Correct. Yes. Correct. Exactly. So there is like one. Sometimes it's not just one. Sometimes it's like 2 or 3 numbers. But in the whole model, there is like a few numbers which you need to identify, not to quantize. And by not quantizing them, you will increase accuracy. If you do quantize them, then your model will decrease accuracy from like 80% to like 10%. So like you have to find these like small little numbers. Yeah.
Interesting. So in the next session of the pod, we are moving more towards RL and reasoning kind of questions. So the first one is about if a model could retroactively undo gradients, what property of the reward signal would cause it to say, yeah, that was a mistake? What might the next generation of RL objective learn from that? Yeah.
I think in my view, currently the our algorithms are generally actually not that bad. My view is like, the goal of RL is my phrase that I like to like tell people is like luck is all you need. So my view is like, the longer you wait, the better your algorithm will be. So over time, your algorithm will learn. So like, over a very long period of time, our algorithm will learn over time to increase reward. So currently my view is like most our algorithms, they're pretty good. There can be some small changes, maybe the KR divergence, maybe get rid of that, or like, reduce it to 0.01 or something, small changes. But overall, the goal of these changes is just to increase the efficiency. So like, make the trading process faster, stuff like that. So my view is like, currently RL is pretty good. The algorithms are pretty good. What is missing is the actual reward functions, the environments, the large scale training runs. These are the things that are missing. And so like over time, we will be, large model labs and open source community, we will work on these like small little other things that will make RL much better. So my view is like the algorithm, I don't think so we need any more changes. It's generally fine. Obviously there are like still some extra things like multi-turn is still hard. Multi-turn, multi-environment, stuff like that. These are still a little bit more complicated. But in general, I would say the algorithms are okay for now. Yeah.
Also, what are your thoughts on RL for zero pre-train? Like not like using RL from the pre-training stages and getting up to it. Like not like how DeepSeek V3 was sent. Like DeepSeek V3 zero, at least was from just from RL, but
Train
they
model.
later did SFT and stuff. But yeah, like how do you see just using RL and getting things done from scratch and effectively using a
Yeah.
good fine-tuned model for this stuff? Yeah.
Honestly, I don't think that's a good idea. In machine learning, everything is about efficiency, and every single problem in machine learning is optimization, right?
Yeah.
So like the reason why we do pre-training is for optimization purposes, right? So like you have like a uninitialized model, like just random weights, and then you will like, move in the 1.4 trillion parameter space to get to a pre-trained model. And then after the pre-training step, you do supervised fine-tuning to make an instruction following. And then you will do RL, and then you will do RLVR, right? So like all of these stages, the reason why we have these stages is for optimization, right? To like make the process more efficient. You could, as you said, you could you can remove the pre-training stage, right? Remove it and just do RL, right? From the randomized weights. Yes, that will work. That will work, but it will take millennia, right? I'm not sure if someone wants to wait there forever, waiting and waiting and waiting for RL to actually, solve the pre-training, remove pre-training. My view is you still need pre-training primarily because this is to increase efficiency. So my take is not a good idea. That's my view. You should just do pre-training first. That is very important still. Yeah.
Also, yeah, GRPO is expensive many a times. Is there a path to scaling reinforcement learning for massive models that doesn't involve burning a huge compute? So, what you tried or seen work in practice usually? Yeah.
So the trick is for GRPO is one of the biggest issues is it always seems to follow. It seems to over reward firstly based on format. So like at the very beginning, the model doesn't actually know how to follow the format that you're trying to like force it to do. For example, when you're like trying to do like, please put the reasoning process between think and close think. It first needs to learn how to do that format. So it seems like these RL algorithms, they get stuck. They get stuck before you actually learn how to do RL. Like, before you learn how to like add 2 plus 2 is equal to 4. It firstly tries to optimize for format. So the trick is you have to do supervised fine tuning first. You have to do this priming stage or this warm up phase to force the model to learn the format, and then you can do actual RL. So those are like some tricks that we show. Oh, wait, you need to do warm up. You need to do priming and stuff like that. So this will actually reduce compute by a lot. Like I would say this will make your reward functions much more powerful. The model will learn like maybe 5 times faster. So please, I always tell people, please do some supervised fine tuning step first, and then do RL. Yeah.
So you're more like pushing to optimizing SFT step and doing more experimentation, or coming to an optimization layer that can eventually enhances the SFT thing.
Yeah, so my view is machine learning is just optimization. So like every single thing that you try to do is just optimization. You could, right? For example, you could wait. You could don't even pre-train the model. Just go from random weights to the final RL model. Right? You could just do that. Like, why? That's my question. Like, why? Like, my view is like, this will take too long. There's no point of doing that. I mean, obviously, there is another school of thought, for example, right? There is another school of thought which thinks you should do that. And the reason why you should do that is if you do pre-training, you're already trying to like put biases into the model. Right? The model is like at a local minima. Like it's not a global minima. It's a local minima. So that is kind of what they try, like, most people try to think like that, like you should go from like a pre-trained model, no pre-training, just skip to RL. I think it remains to be seen. Yeah, that's my view. Like maybe a large model lab can try it out. Maybe OpenAI, maybe Google, maybe Anthropic are doing that. I don't know. Like my view is you still need pre-training. And my lens is like you need to view everything as optimization. Try to reduce resources as much as possible. And yeah, that's my take. Yeah.
On the same line, everyone's scaling supervised models, but can RL be scaled so aggressively it becomes the transformer moment for decision-making system in enterprises? Yeah.
Yes, my view is yes. Currently, the RL percentage of the whole training run is only like 1 to 5%, right? Very, very less of the full training run. Pretend we can scale this to 100%, right? Like double the training run. Pretend if we could scale this to like 10 times more. Then we will see results. There is like a research paper which shows that RL, all the updates are very sparse. So like only like very small percentage of all the weights are updated. And the reason why is because you only trained it for like 1 or 5%, right? So like of the total training run. You haven't really trained it that much. So my view is over time, yes, if you scale RL to large scales, you will see interesting phenomena. You will see the model actually learning how to do lots of stuff. And yes, but this will take more resources and more time. My take is if the probability of a positive reward is more than 0, and if you execute RL to the maximum limit, in the limit, you will get a very powerful model. That's kind of what I think that's where most large model labs are trying to like go for. Their view is like, if you can scale RL to like infinity, you will get AGI. Yeah, that's kind of what they think. Yeah.
Also, in the same line about this transformer thing, Google has tried a recent work and earlier work with Titan paper to that they have shown that this transformer architecture can be better be optimized with those. So how you look up to like, is there something that need to be yet improve the transformer architecture, and how you see the recent progress being done so far to actually overcompensate transformer movement and get something new or novel? Yeah.
My view on the architecture side things is, again, it's optimization, right? So like the goal is to try to get a more efficient architecture, to move the scaling laws, to change the multiplier of the scaling laws, or change the the exponent of the scaling laws. in my view, the current transformer architecture, okay, see it's a transformer architecture. I would say it's called the Transformers plus plus architecture, right? So like it has like it's more like the llama architecture. That's pretty good. So like, there's the MLP, there's the Swigglue activation, there's the attention part. DeepSeek, I would say DeepSeek did innovate somewhat in the architecture type realm, right? So like they introduced they introduced some changes to like the attention part. They added MOEs, MLA. So like they did innovate in some areas. But my view was like there's not that much left to innovate. That's kind of my take. So like my view is like it's better to like better to innovate on the algorithm side things and less so on the like architecture side things. Yeah. So like I think the transform is pretty good. Yeah, in my view, I really like the transformer. It's very effective. Yeah.
Pretty interesting. Like you are playing around with the most low level set of things, getting transformer, like seeing transformers is actually working well for most of the architectural setups. Yeah, makes a lot of sense. So how does you see this fine tuning space evolve? Will we see more RL based fine tuning coming months or days? So there's a lot of work happening here, like ART from Open Pipe and stuff. So how you do see on the more high level side of things? Yeah.
Yeah, like highly recommend art. It uses Unsloth under the hood as well. But like I think I am very eager to see more RL fine-tuning frameworks. I think this probably is the future. I think SFT, general fine-tuning, you can pose the question as a RL question. And I tell normally people, like, if you want to reduce overfitting, please, try RL. RL definitely reduces overfitting a lot, because you force the model to try to learn how to do the task. And your supervised fine tuning is more like overfitting to like try to do instruction fine tuning. It can sometimes not be that effective. So I generally tell people to do RL more. And yes, everything is about optimization again. So like there will be more about how do we make RL more efficient, how do we make RL faster, and stuff like that. So like always about efficiency optimization. So yes, I'm very excited for more RL frameworks. Yeah, we also obviously tried Unsloth. Yeah.
So I guess the next section is about Unsloth only. I've got a lot of questions about how Unsloth does and many such questions to be explored. So the first one is about, uh, so you were deep in the weeds of LLM optimization. So when did the idea of actually starting Unsloth crystallize? When did it came to mind to pivot to startup with Unsloth itself? Yeah.
So we did it in Europe's competition. So this was like a few years ago. There was a LLM efficiency challenge. I think this was run by Mark Serafim and like some other people in Europe's one of the workshop type things. And we were trying to participate in that. But in the end, instead we did something else on the side. It was kind of like a reincarnation of Hyperlearn. So Hyperlearn, was the faster machine learning algorithms. What we did is we made training language models faster. So we wrote Triton kernels, we wrote, reduced memory usage. It was primarily so like we could submit within the 24-hour window. So the competition, you have 24 hours to train one model, and your goal is to make this the fastest, the most accurate as well. But we went another way. We went for the fastest training. So our view is if you can train the model faster, you can get high accuracy. And so, we launched the package around December 2023. And like it was mainly just an open source package. And it was just for fun. We posted on Hack and Use the first day. It kind of bombed. The second day it did pretty well. We went number one Hack and Use. We posted on Reddit. It took a few days for like people to notice Unsloth. And then we currently have 40 something thousand GitHub stars. We have like 10 million downloads on Hugging Face and stuff like that. But it was a very long journey. And definitely if people want to train train language models, definitely give Unsloth a try.
I guess you pretty much enjoyed the December 2023 to how it has came up so far.
Well, obviously at the beginning, it was a very long process of at the very beginning when you start like a startup, like, we didn't know how to like launch a startup. We didn't know how to launch an open source project that was like getting lots of users. At the very beginning, there was a very large amount of popularity for Unsloth. But, normally it will die out, right? It's normal. But then, you have to keep going at it. Like we kept uploading stuff, we kept making Unsloth better. We just kept doing the stuff that we liked. And so like over time, okay, we got more usage and stuff like that. So it was a very long process. But yes, obviously, I'm very proud of Unsloth. I'm very proud of the community, and I always appreciate the community for like supporting us. And yeah, like I'm a fan of Unsloth myself, right? Obviously, and so like I'm very excited for like every single day, to like make Unsloth much better. Yeah, but it was a very long process. Yeah.
Also, I'm curious how you came up to the name Unsloth. What was the idea behind
That's
it?
my brother. My brother came up with the name. So obviously, like Unsloth, the sloth is like a slow animal. And then we un it. Right. The whole goal of Unsloth is to make faster training.
Oh,
And so like we came up with my brother came up with the name. Oh, okay, it's like, not slow sloth, but like fast sloth. Yeah, it was just a play on that. Yeah.
I've got a bunch of DMs how Unsloth came up to actually naming it. And also, I'm curious about how SF is basically like your based in SF, how SF is about accepting open source packages, more specifically about Unsloth, not just about Twitter, because I guess more people talk about in the community who are actually deep involved in the like doing fine tuning open source stuff, but how SF is actually as a market accepting open source softwares, and yeah, Unsloth as well. Yeah.
Yes. So we moved to San Francisco, the US, last July. So like July 2024. Primarily for Y Combinator. So we were part of the S24 batch for YC. And so like, it was kind of like we had to move to like the US, to do YC, but it was actually very good. So the reason why the US is good, and especially SF, is because everyone is here, right? So like you have, Gemini is here, the Meta office is here, everyone is here. And so if you want to get information about models, if you want to get information about like, what's coming up, or like, what's happening in the AI space, SF is the first place where you're going to hear this information. So our view is like, if you're trying to make a startup, please come to San Francisco. Obviously apply to YC, but like, San Francisco is the heart of AI. And yeah, that's kind of our view. And yeah, everyone in SF is like, very ambitious. They want to like make a very large company. So like we fit in very well with them as well. That's kind of our goal as well. So like definitely as a startup founder, SF is very, very good. Yeah.
Also, I'm curious about how was the YC experience and how exactly YC helped in initial stages of Unsloth. Also, what was the vision for the product and scale long ahead?
Yeah, I think the primary help for YC is we are from Australia, and because we're from Australia, we don't know how to actually run a company that well. And YC kind of taught us like how to focus on user growth, how to focus on running a startup correctly, how to like connect with companies and founders, how to like learn about how to actually run a company. I think that's the main like focus. And also YC's view was like the biggest issue when we were in Australia, most people didn't really want to run like a very large company, right? They don't want to make the startup as big as possible. They were more like, like trying to get a good job, be stable and stuff like that. But visions were different. We want to make the company as big as possible, right? Like our goal is to make AI accessible to everyone. That's our goal. And we didn't have like a peer group. There was no one to talk to have like ask him for like issues. We don't even know how to like open a company. And so like YC was a very good experience to force people to learn how to open up a company. So it was, yeah, I would say the benefit of YC, it's forced learning. It was a forcing function for you to make a company and make the startup good. So yeah, like definitely apply to YC. That's what I always tell people. Yeah.
Also, what's the go-to-market strategy for Unsloth? Any consideration to start privatize products along with OSS in coming years?
Yes, we are going to be planning to launch products later this year. They are in production. So our view is like we were thinking of like doing some sort of like inference or training platform that might be still on the roadmap, but we're not sure yet. Our view is we need to make products. So you will see some very cool products released from Unsloth. I can't say anything yet, but it is related to reasoning. It is related to reinforcement learning, and this will come out in definitely this year. Yeah, but our primary objective is still to make the open source as big as possible. Our primary objective is to make AI accessible to everyone. That's the primary objective. But yes, you will be seeing many products from Unsloth. Yes.
Pretty much excited, and I guess Unsloth has got the scale and the distribution in the community. I see like it's getting adaptably really well.
Okay, well, thanks a lot. Obviously, like our thanks as always to the community. I think like the community definitely is the reason why we're here. So like we're always thankful to the community that like made Unsloth how it has become currently. Yeah.
Also, I got this question: what are the plans for Unsloth to support decentralized training?
It's a good question. My fundamental view is decentralized training is basically decentralized training is opposite to what NVIDIA wants, right? So like, and large model labs, right? So like this is kind of in opposite to large model labs. They want all of the training to be done in like one large data center, right? So like that's kind of their view. The reason why you want to do that is you can, if there is one GPU broken, the engineers who fix the GPUs who like broke are already there, right? So like you don't want to suddenly one GPU to break and then try to fix it and stuff like that. So that's why they're all housed in one data center. So like you can also reduce cabling, you can reduce wiring, you can reduce cooling. All of the costs are just in one data center. And so it is obviously in direct contradiction to decentralized training. Right? So like, but my personal take is you should probably still do large training runs in centralized training centers. Like this is just to reduce cost. For decentralized training, maybe we might support it in the future. Maybe. Probably not now. We will have to think about it. In my view, so the biggest issue for decentralized training is it's not the training on each device that's the problem. It's the actual synchronization of gradients, synchronization of like, moving the weights around. That is the biggest problem. The communication is the problem, right? So the communication cost. That's very, very, very expensive. So my personal take is, if you want to do large training runs, I would still do it in a centralized data center. Yeah, if that answers the question. Yeah.
And I guess pretty much all these big frontier labs are working around that direction, unless if they are looking up to decentralized training. Also, I'm curious, just want to get a sneak peek. What's the next big thing Unsloth is working on?
So we are working on Unsloth version 2. So this will make training much more efficient, reduce memory usage dramatically, make RL very efficient. So like that's probably the next big thing that we're releasing. We are also working on a UI. And so like there are many things in the pipeline. So there is actually a lot that we are going to release. Yes, including AMD support, Intel support. So they are actually working with us directly to make it work inside Unsloth. So maybe in the next few weeks and months, you will see lots of releases from us. But yes, there's a lot in the roadmap. Yeah.
Interesting. This was a nice question I got. Unsloth does a lot of clever monkey patching. Any Python hack you are proud of that looks cursed at first glance but works if beautifully in practice later?
Yes. Some people don't like us for this, but there was like a Twitter storm saying, our monkey patching is not very good. But in my view, after we had two thinking methods. Okay, thinking method 1, do not do monkey patching and copy paste or like, vendor implementations and edit in the actual implementation. So like actually make the implementation like efficient and stuff like that, right? Like have one Python file to do this. We tried that. It does not work. Every single time there's a new architecture, there's a new bug fix, there's a new, every single time the AI field is moving every single day, and it never worked. So what we did instead is we did monkey patching, and the most proud thing that we did in Unsloth is we have something called the automatic compiler, where we will inspect the transformer's code and we will edit it. We will edit it on the fly. Like we remove one section of the code and we will like replace it with an optimized version. And so that's kind of what we're most proud of. It's very hacky. It is very hacky. Essentially, we will read Python code on the fly, edit it, save it to a Python file, and then import from that new file. It's kind of like a compiler. It's like kind of like Torch compile, where there's like template matching, like switching templates out and switching implementations out. It's kind of like that. And Python is very powerful because it allows us to do that. Some people don't like it. Some people don't really like doing that. But from our view, it is the most efficient and the most effective way to make transformers more efficient. Yeah.
Interesting. What you see is the biggest differentiator for Unsloth in terms of training, speed improvements. So Git is reducing memory overhead actually leads to bigger batch sizes and therefore better util. Can you rank or give more specifics on order of importance on tricks, kernels, remat, things you have done for custom gradients? Yeah.
I think in terms of Unsloth, the biggest differentiator is not our speed ups. So we are 2 times faster than Hugging Face plus Flash Attention 2. We do reduce memory usage by 70%. We introduced, gradient accumulation bug fixes, async gradient checkpointing and stuff like that. The biggest thing I would say is not actually the faster or the memory reduction. It's not. The biggest thing is how do we combine all the things that we do into one package? Like, for example, how do we do quantized models? How do we load in Unsloth dynamic quants? How do we, apply our bug fixes to all the models? How do we export to VLLM or ggwef or, Llama CPP or Olama or, or LM Studio or something like this, right? How do we export the model? How do we do chat templates? How do we do RL? How do we there's all these small little things that we try to solve for. And I think that's where the power of Unsloth is. It's not actually the optimizations. It's the conglomeration of everything that we do into one system. So I think that's where Unsloth shines. Yeah, I don't think it's just the memory reduction or yes, people really just like the memory reduction, right? Some people really just like the memory reduction. Some people really like the speed ups. Some people really like the kernels and stuff like that. But my view is it's the entire system, the most important. Yeah.
Also, just curious, what's the most embarrassing way you have broken a model or pipeline, and what trick made it work next, if any, on the same note?
It's not really, I wouldn't say it's embarrassing. It's this is a very common issue. Okay, this is a common issue where, so we solved gradient accumulation. So there was a bug fix that we did last year where we told all training frameworks, nearly all training frameworks had this issue of gradient accumulation. We solved the problem in our package and we worked with transformers to make it work. And we helped other packages solve it. The issue currently is sometimes people forget to patch for gradient accumulation. And so sometimes when you run a model, you will see very high training loss.
Yeah.
You will see the loss as 7 or 11 or 12. It's definitely wrong. So I always feel unfortunate that we fixed the bug in the gradient accumulation. There's more bugs. So essentially we fixed one. It's like a whack-a-mole. We fixed one bug, and then the moles, we whacked one mole, and then the other moles came out. And so I wouldn't say it's embarrassing. It was more it's an unfortunate consequence of us fixing one bug. It resulted in more bugs. Yeah.
Interesting. And the next section of this pod is about general questions. It could be some trivia, or it could be some doubts, or some want to know a hack behind Unsloth. So moving ahead to those. So yeah, it is about would like to clearly know how you are using offloading and remat to drop memory uses during training without reducing speed. Like people know that there are some papers, but heuristics is Unsloth using something under the hood. Yeah.
Yeah, so we introduced something called async gradient checkpointing last year. So what you do is when you do training, there is a trick called activation checkpointing or gradient checkpointing, where you have to recompute a layer. And the reason why you want to recompute the layer is so you don't need to save the gradients. You don't need to save the intermediate activations. But the problem is these activations you still need to save interlayer. And so like the trick is what we showed is you can actually save this to RAM. You don't need to put it on the GPU. And this will reduce memory usage dramatically. But the trick is this will reduce speed because you're like transferring the GPU memory to CPU. And what we show is you can actually do this async. So we have in our package, we use CUDA streams and we do this very effectively. And so this will make training like 0.5 to 1% slower. It's not that much difference, but you will reduce memory usage dramatically. Maybe like 30% to 50%. Yeah.
Also, on the ecosystem of GGF, MLX, CUDA, etc., which one you think has the most potential for consumer devices?
Definitely GGF. Our view is like, Llama CPP. It's not the best, right? It's obviously not the best in like, optimization, throughput. If you want throughput, use VLLM, right? Llama CPP and GGF is the most universal format and it's the most stable ecosystem. So like my view is this Llama CPP will always be here to stay. And whenever there's like a new optimization from VLLM, the Llama CPP folks will add it. They're working on something called high throughput mode, where the aim is to become VLLM. So like I think my view is Llama CPP is the most. It should be the ecosystem where everyone's trying to go for. And then obviously CUDA, VLLM, MLX, other systems are also very important. But my view is Llama CPP is the go-to framework for serving models. Yeah.
Interesting. So do you feel FOMO with respect to so much happening in this field? Your work seems to be focused on more training, inference, optimization, but other areas exist like modeling, etc. So example could be, it might be tempting for you to experiment with architectures, linear attention replacements for training, etc. So the whole point of the question is, how do you stay focused with so much happening around? Yeah.
So the good thing is because we're a startup, our primary objective is to get as many people to use Unsloth as possible. That's the primary objective. The objective isn't to make training faster. It's to expand. Our goal is to make AI accessible to everyone, right? So like our primary objective is to reach as many people as possible. So that's how we stay focused. Like for example, if we want to experiment with linear attention, we firstly ask the question, if we do linear attention, or if we like optimize this specific area, how many people would this, will utilize this method? So that's kind of our question. And if we have to do like a cost benefit analysis. So if I want to optimize, right? My personality is I will optimize the hell out of like a system, right? But that's my goal. But I can't, right? Because everyone only has like a few hours in a day. So my question I always ask is, how many people can we reach if we do this? So that's kind of like the question that we always ask. That's how I stay focused. Yeah.
This makes a lot of sense. The next in the line is multi-GPU coming?
Yes. Technically it already works. So if you use accelerator and torch run, Unsloth does work on multi-GPU. Yes. However, we are working on a more efficient and much more easier to use system. So this will be part of Unsloth V2, which we'll be releasing in a few weeks to maybe later this year. But yes, it does work. We actually have docs for it. So if you type in Unsloth multi-GPU, it will tell you how to run it currently. Yeah.
Interesting. Pretty much excited about the version 2. Also, I got a lot of questions around this. So what are some good stuff to get started optimizing LLM speeds and efficiency using Triton? Any some specific resources, or would you like to recommend or something which actually helped you or made Unsloth better along the way? Yeah.
Yeah. So I generally recommend people to learn the Triton, go through the Triton tutorials. So the Triton tutorials are very effective. Probably skip the flash attention part and the other more complicated tutorials. They're not that important. Just skip that. And then I would turn on Triton interpret is equal to 1, write Triton kernels, and essentially just trial and error. Literally try to write to the kernels and stuff like that. In fact, a very good trick that I tell people to do is do torch compile, set torch compile debug to be true, and then inspect the Triton kernels that are generated by torch compile. And this is a very good learning method. So yeah, that's kind of how I tell people to learn Triton. Literally just take Triton, torch compiles Triton kernels, and just read through them. The more Triton kernels you will read, the better you'll become. Yeah, and also like another way is like rename all the variable names. So like if you do torch compile, you'll see a lot of like temp11, temp13, temp33. Try your best to like normalize all these names. And yeah, but like that's how it. So do the Triton tutorials, and then read torch compiles Triton generated kernels.
Also, like there was this agent which writes CUDA kernels for your own. Like you don't have to actually uh, work around it manually. So how you do look up to that space and like it's actually a big bottleneck for people to understand CUDA kernels and start writing from the scratch. But how do you see the space that yeah, I've got this agent framework which is gonna write my kernels just by manually prompting it. Hey, just write this kernel for me. Yeah.
My view is, I think my take is these systems where you like automatically write kernels. I'm not sure who are they trying to compete with? That's my main question. Like, I'm assuming they understand that torch compile exists. I'm assuming they do. And my view is like, they're trying to like make it much more efficient than torch compile. But my view is PyTorch team are very smart, right? So my view is like the PyTorch team is extremely smart. And over time, torch compile will get better and better and better. And you must focus on mathematical algorithms, right? So like writing like new mathematical optimizations. And I think that's the automatic CUDA kernel generators are very bad at generating these, new maths algorithms. And that's where they suffer dramatically. So like I think this will still require some labor to make it work. But my view is like I'm not a very big fan of the automatic kernel generators. My view is just use torch compile. It's my view. And then focus on, mathematical algorithms. Yeah, that's kind of my take.
Also, what were your biggest obstacles in your journey, and how did you overcome it along the way?
The biggest obstacles was in fact my understanding of maths and transformers. I think it's probably a very big obstacle for everyone. I think
Yeah.
the deriving gradients, like, for example, how do we do backpropagation by hand? That is the hardest thing someone can do. So my view was like, if someone wants to learn how to do machine learning from scratch, how to do Triton kernels, learn how to do backpropagation by hand. And then once you learn that, then you can optimize. Okay, you can bracket it this way, or fuse the operations this way and stuff like that. So my main point, my main learning lesson was learning how to do backpropagation by hand was the most important. And it was a very big obstacle, right? Because you need to learn maths, you need to know how to do unit differentiation, you need to know how to do matrix calculus. So it did take a lot of time. That's why I think my maths background kind of helped. I did do some mathematics and I did linear algebra, statistics, so it definitely helped. But that was probably the biggest obstacle.
I guess you are biggest fan of building foundations from scratch, coding, and
Oh yes.
on the foundation stuff. Yeah.
Oh yes, definitely. Definitely. If you essentially, I normally advise people to learn not from scratch. It needs to be scratched with a project, not just learning fundamentals and stuff like that, but there needs to be a project tied with it. And it seems to be very, very effective. Yeah.
Interesting. So like I actually missed this question. You have worked at NVIDIA as well for a couple of years. So how
Yeah.
was your experience at NVIDIA? What actually you worked on, and what excited you more about the stuff you were doing there? And how much it has impacted your current stuff, what you're doing now?
Yeah, yes, I did used to work at NVIDIA. So I was part of the QML Rapids team. The goal was to make machine learning, to make machine learning faster on NVIDIA GPUs. So it's kind of like what I really like to do. So I was part of the QML team. I made TSNE, so a data visualization algorithm, 2,000 times faster. I made like randomized SVD faster, some other algorithms faster as well. I think working in NVIDIA was very good because the NVIDIA folks are like, they don't require you to do anything, but they do want you to do something by yourself that can impact a lot of people. So like they're very hands off. So like in my view, if anyone wants to work for a company, you should definitely try NVIDIA out first because their way of organizing people and giving projects to people, they are very they want you to be self-autonomous. So, people like, yeah, I find like, when I went for NVIDIA, it was kind of like a precursor to running a startup. So yeah, I highly valued the experience of NVIDIA. Yeah.
I'm also curious about so the current stuff we are actually doing. We are building Mindy AI cursor for apps, not juggling between apps. So I'm just curious about what is your take on current agentic space, which most of the startups currently working on, and how you do see, because it's been said that 2025 is the year of agents, and people are just working around tool calls, function calling, and getting stuff done on the fly. So how every other day we see tens of startups products launching around agents. So how do you see it, and what goes beyond it? Yeah.
Yeah. So my view is like for agents specifically, definitely the target audience is very interesting. My view is the majority of the revenue and the growth is going to startup founders. They want to open like some sort of company, so they might use Lovable. They want to use, they will use Cursor to like write code to make like a product. So my view is the majority of the audience is still in the startup ecosystem. Like people who like utilize these tools are mainly startup founders. That's my view. However, there is the other side, like people who use Claude for coding, use ChatGPT. ChatGPT, for example, right? Everyone seems to use. My parents use it. Right? My mom uses it. My dad uses it. Like ChatGPT is just so pervasive. Everyone uses it, and so like there are two different areas. Yes, I would say that specifically for agents and like making these systems to like code up like temporary demos and stuff like that, it can go somewhat some far, like some way, but there is like a very I'm not sure how far this can go. Like there are like many different issues. Generally, if people utilize these tools, you definitely can start up a startup, right? So like the whole goal of making a startup is to know what people want. What can people will something make something that people want. And so like definitely these tools are very helpful for that. But it might not get you to the very end. But I do agree these tools are very helpful. So for example, we use these tools as well. So like, yeah, so my view is these tools are very effective. Yeah.
Interesting. And I guess now everyone is getting adjusted to how better productive they can be using these agents and getting things on the fly. Interesting. Next in the slide is yeah, how to become a good experimentalist.
There there is no set formula. I think it's more like just you need to have curiosity and patience. That's all. Just those two factors: curiosity and patience, and just trial and error. There is not that many. There's not that many like tricks I can tell people. It's just patience and patience and yeah, just literally be patient and curious. Yeah.
Curious. Also interesting. What you think of AGI, or basically post AGI world? Yeah, that should be bit off. But what's your vision? What you're thinking around this?
That is complicated. I think my view is firstly we need to define what AGI actually means. I think that's
Yeah.
the question. Most people, when they mean AGI, like the general public, they mean like Terminator, like something that like is very smart, X machine or something like that. Something like that. I think the definition of AGI is complicated. My view is like, is it what is actually AGI? is it a system that is smarter than all humans? Is it a system that's smarter than 99% of humans? Is it a system that's smarter than most smart humans or something like that? Or is it a system that's smarter than the average human? There's many different definitions of AGI that's very complicated. So I think that's the question. Is AI smarter than an average human? I would say yes. Clearly, ChatGPT is in fact smarter than an average human. It's very smart. However, it can't do human labor, human tasks. Right? It can't do the laundry. It can't cook or something like that. Does an AI have to do that? Remember, it's called AGI, as in with intelligence at the very end. It's not like a human. We don't. It just needs to be intelligent, right? It doesn't need to do all tasks. But I think so. My take is it depends on the definition of AGI. Yeah, in a post AGI world is very complicated. If we're going to be talking about a post AGI world, my view is it's kind of like game over. What exactly can we do? To my point. So my fundamental view is it's going to be very hard to get. It's going to be very, very hard to get to a post AGI world. That's my personal take. Yeah, I'm more the conservative side. Yeah.
So, do you think something that is more fundamentally broken about how we are thinking about the progress to AGI?
No, well, if I was a large model lab, this is I would think about if there is a small probability of reward functions to be positive, I would just try to scale this up to infinity, and over time you will get AGI. That's kind of what they think. It's their view is the longer you run RL for, you will get to AGI. See, that's actually what I think as well. That's my view as well. My view is yes, you can get to AGI. You just need to scale RL dramatically. The timelines are different. So my view is the timelines are much longer. Maybe the AI labs think the timelines are smaller, maybe I don't know, this year or next year, I don't know, in a few years. My view is this will take much longer. There are different jumps in terms of capability. When ChatGPT was first released, we had something called the SFT jump. ChatGPT was just extremely powerful because it could do instruction fine-tuning very well. And then we had O1, which is the RL jump. So my view was there's always these types of jumps. Maybe there's no more jumps. There's no more jumps in capability, and it's just very slow improvement. So my view is we can get to AGI, yes. But how long? So that's the question. How long would this take? I'm not sure. Yeah, that's my take.
Interesting. Also, what do you think about this benchmark maxing thing by closed source models, just setting on a benchmark, improving the model? It has become a certain loop for every other closed source model to come into picture. What's your general overview of this?
Yeah, I'm not a fan of bench maxing or whatever you want to call it. But I think some models actually do show some good results. For example, Gemini 2.5 Pro in the IMO challenge. If you use the public version of Gemini, it does get, I think, 33% or something. So it actually does not do bad. So sometimes some models do benchmarking, and it's, I understand what they're trying to do. They're just trying to go for benchmarks and stuff like that. It makes sense. It's a very human thing to do. I forgot what the law was called, the Lockhart's. Wait, I forgot which one. When you try to optimize for the benchmark and the benchmark becomes useless. Goddard's law or something. I don't remember the name, but there is a law about that. My view is yes, benchmarking is probably not very good. It's a starting point. It's a starting point. That's my view. If your model can't even overfit on benchmarks, then you're definitely not doing something right. That's my view. So if your model does overfit on benchmarks, at least you're doing something right. And then the next goal is try to make this more generalized. Yeah.
This reminds me of this recent Grok 4 release on this AIME 2025 benchmark. The Grok 4 does most 100% of the accuracy, 100% of the on this. They're just. I'm just curious, what could be the next thing about if it. So, do you really see that could be a thing a model can get if that is not benchmarked? So a model can generally get the 100% of the accuracy on the on that particular benchmark or any other. Like I see it is a good hard benchmark to get 100% of the accuracy. But what's your general take on that? Like getting 100% accuracy in any benchmark? Yeah.
My fundamental view is life is just benchmarks. Like every single thing that you do is a task. And this is how I view it. Assume you can taskify, like convert everything into a task, right? In the whole world, there's like billions or like trillions of different task combinations, and you make the AI do all these tasks with perfect accuracy. Right? Every single task gets perfect score. Right? It can do mathematics, it can do multiplication, it can do division, it can make a poem, it can make code, it can do every single task perfectly. Is that AGI? Like, is that the definition of AGI? So my point is, benchmarking is not good. Yes. Okay, fine. But you have to start from somewhere. Right? So like my view was like, if you can do benchmarking, it's not bad, but you need to be able to update the model continuously with new benchmarks. So my view was like, you need to keep making more benchmarks. And make the model learn on all the benchmarks. And then over time, you will get AGI, maybe. Yeah, so like, okay, I don't know if that's a controversial take. Like, is like life just a benchmark? Like, benchmarks are like tasks. But like in my view, like if a model can do every single task a human can do, I can't distinguish that from, it's very hard to distinguish whether this is a human or not a human. So yeah, that's kind of my view. Yeah.
Interesting. I guess we are pretty much into the end of the pod. I'm just curious about what advice you're gonna give to 20-year-olds who are just starting out college, don't have much idea about the current AI space, which is turning 360-degree after a week, and advice for young founders as well, like they're building around ML infra and very low levels. So what should they look up to and beyond? Yeah.
Yeah, I highly recommend, lecture videos by Andrew Kapathi on YouTube, Jeremy Howard's videos, Fast AI videos, CS229, CS231N, some other courses on the internet. Also, Unsloth notebooks. So like we do have notebooks on our docs for like continuous pre-training, continued pre-training, supervised fine-tuning, reinforcement learning, GRPO, many notebooks for each model, Llama, Mistral, Gemma, all the models. So definitely go for that. And yes, like I generally tell people to like learn some linear algebra. It's not that important, but do learn how to do matrix differentials. How do we do the derivative of the weights? Learn how to do backpropagation by hand. So that's very helpful. And also the most important thing is to code a transformer from scratch. How do we do the Llama architecture from scratch? Just PyTorch code, nothing else. That's what I generally advise people to do. Yeah.
Yeah, I guess this was pretty much end of the pod. So I guess this was super fun, at least for me and you for as well. What I found fascinating is how speed wasn't just a technical obsession, but kind of philosophy you have developed running through everything you have built so far. Curious to see how far you can push these both with Unsloth and whatever comes after, and looking forward to Unsloth version 2, what's coming. On the final note, if you have to share some notes, some thoughts about the current space, how you are looking up to the future, the AGI thing, and how should people look up to anything you wanted to share?
Yeah, so my final thoughts is like, I would say to people, don't be afraid of AGI. Like, it's not necessary to like think about, like when is AGI going to come? Or like, if I do coding, will my job be automated away by AGI? You don't need to worry about that. My fundamental view is if you do something that you like, and keep doing the stuff that you like, you'll be fine. And if you want to keep up with the latest research of AI, my suggestion is don't keep up with the latest research of AI. It will drown people out. Always like if there's a new research paper or a new model and stuff like that. But if you do, definitely follow me on Twitter, follow Himanshu on Twitter as well, for example. So like, yeah, like we will, there is a lot of papers that, that are interesting that I will share about. But in general, definitely thank you for inviting me on the pod. And excited for more podcasts as well. Yeah, thanks a lot.
Appreciate you joining, Daniel. Thanks so much.